Hello and welcome to the review for Spiral 14. We're going to start off with this stuff all the way back from cycle 12. This is the first time that we've seen this graded, and we're going to identify some zeros for the following polynomials. First one I'm going to look at is 4x squared minus 49. I'm going to write that as 4x squared minus 49 is equal to 0. And I'm going to treat this as just a solving thing, so I'm going to add 49 to both sides. So I get 4x squared is equal to 49. I'm going to divide both sides by 4. And that leaves me with x squared is equal to 49 over 4. I'm then going to take the square root of both sides to get rid of the squared, and that gives me x is equal to, I need this plus or minus. This is really important. And square root of 49 is going to be 7. Square root of 4 is going to be 2. So plus or minus 7 over 2. Moving on to the next one, 2x minus 3 is equal to 0. And that gives me x is equal to 3 over 2. And then I've got 5 minus 4x is equal to 0. That gives me 5 is equal to 4x. And then if I finish that off, 5/4 is equal to x. So my zeros are plus or minus 7 over 2, 3 over 2, and 5/4. Moving on, we got to do some factoring. This first guy, I can take out some stuff because this is looking not so pleasant. I'm going to start by taking out at least a 5. And when I do that, I get 10p squared. 285 divided by 5 is going to be 57. And then 270 divided by 5 is going to be 57 less 3 is going to be 54. Cool. So now I'm looking for ways to keep going with this. Just to make sure I can't divide by anything else, 1, 2, 5, 10 could be divided by my 10 there. 1, 2, 5, and 10, none of those are going to reduce these things. So we have a starting point of a times c is going to be 540p squared. And we're looking to add up to 57p. Okay, I'm going to start with 1. So we got 1 and 540. That's a no. 2 and 270. That's also a no. 3 and that's going to be 118. So 180. Nope. 4 is going to be 270 divided by 2. So that's going to be 135. 5 is going to be 108. 6 is going to work as well. 6 is going to be 90. 7 is not going to work. 8 is not going to work. 9 is. It's going to be 9 and 60. 10 and 54. Now we're getting closer. 11 doesn't work. 12, I've got a pretty good feeling about this, is going to be 12 and 45. Woof, we have our winner. So I'm going to bring this down. 5 out front, we're just going to leave that there. 10p squared plus 12. It might be nice if I wrote these in order. 12p plus 45p plus 54. And I'm going to look at things that these guys have in common. 10p squared and 12p, those can both be divisible by 2 and a p, leaving me with 5p plus 6. And that 5 is still just out in front. And then for the next ones, I've got 45 and 54. Both those are divisible by 9. And when I do that, we get 5p plus 6. That leaves me with the 5 that's out front. 5p plus 6. And then we're going to have whatever my leftovers are, 2p plus 9. That's fully factored. For my next one, I already have 4 pieces. I'm going to try to factor by grouping and see if this works. And to be fair, that's the only method I know for this, so it kind of has to work for this to be okay. And we've got x squared and x plus 4. All right, then the next ones I've got minus 4 that I can take out. And when I do that, I get x plus 4. We are in good shape. This is going to turn into x squared minus 4 and x plus 4. One of the things that we've been hopefully noticing more and more is that sometimes we can factor out things that are still squared. This is going to be something called the difference of squares pattern, which is going to factor into x plus 2 and x minus 2. If you'd like to instead treat this as a standard quadratic, the way that we do that is write this as x squared plus 0x minus 4, and then do the same type of factoring thing by grouping to see what this turns into. If there is a pattern that is useful to know, it is this difference of squares, and it's always going to be the square root of the first part plus the square root of the second part, and then what we call the conjugate of that, which is going to be the square root minus the square root of the second part. Cool. Number 3, we're going to factor to find some zeros. First thing I notice is I can take a 3 out of this whole thing. So we got x squared minus 2x minus 3. This inside is going to factor really nicely into x minus 3 and x plus 1. Cool. My zeros are going to be x equals 3 and x equals negative 1. I know I'm going to have to graph this. I'm just going to plot those 2, 3, and 1. My coordinates of the vertex, I'm going to find the average of these two. So that's 3 plus negative 1 divided by 2. And that gives me 2 over 2 is 1. So we're at 1 comma something. To figure out what that something is, I'm going to plug that number 1 back in. So if we do 3, 1 minus 3, 1 plus 1, and just, by the way, that comes just from this equation. I could also plug it back into this. It doesn't really matter. But when I plug that in, we get 3 times negative 2 times positive 2, which is going to be negative 12. Okay. And I'm just going to graph that as well. So that's going to be somewhere down here. It's at 1. I'm just going to draw a nice line of symmetry down here just so I can see what's going on. And that's at 1 comma negative 12. And then the last piece of this is to find the y-intercept. That's where x is equal to 0, so I'm going to plug that in. I could use either of these two forms of my equation. I like using standard form for this because it's a little bit easier to see. So we get g of 0 is equal to 0 minus 0 minus 9, which is negative 9. So we're looking at negative 9 for my y-intercept. All right, nice sketch of this. We're going like this, down through my y-intercept, my vertex, and back up with my awesome-looking parabola. Next up, we got to use the quadratic formula or completing the square. We got to use each of these at least once. You will be given the quadratic formula on your spiral, so you do not need that memorized. I care much more about you knowing how to use it. This first one is set up kind of nicely for completing the square. I know that for completing the square, I've just got to get this part by itself. So it might be nice to begin by doing that. So we got x squared minus 10x is equal to positive 27. I'm going to move that to that side. I'm going to break this middle up into 2 equal pieces. So x squared minus 5x minus 5x, I'm going to leave a space, is equal to 27. Now I'm going to complete the square. I'm going to multiply those pieces together. Minus 5 times minus 5 is plus 25. And because I need to not break my math laws, I'm going to add 25 to both sides. All right, let's factor the stuff on the left side. That's going to factor into x times x minus 5, and then minus 5 times x minus 5, which is going to factor in turn into x minus 5 times x minus 5, which is x minus 5 squared. On the right side, 27 plus 25 is going to be 52. Square rooting both sides, we've got x minus 5 is equal to plus or minus the square root of 52. To finish this off, we're going to add 5 to both sides. We get 5 plus or minus the square root of 52. If you'd like to reduce this, you can, but I'm okay if you don't. By the way, reducing this would be x equals 5. 52 is going to be 13 times 4. So the 4 can come out, as the square root of 4 is 2, and we end up with 2 square roots of 13. For our next one, I'm going to use the quadratic formula. This is kind of a gross-looking problem. I'm going to see if I subtract 6 to the side, if I can divide by 7. I don't know that that's going to be something I can do, but that's okay. And if I do that, we get 69, and that is not divisible by 7. So we're going to set up the quadratic formula. So first thing we have to do is make sure this is equal to 0. That's what we just did. We've got A is equal to 7, B is equal to 14, and C is equal to 69. Negative 14 over 2 times 7 plus or minus the square root. B squared is going to be 14 squared. That's going to be 196. Minus 4 times 7 times 69. And that's over 2 times 7 as well. Let's simplify the stuff on the inside. Negative 14 over 14 is going to be negative 1. Plus or minus over 14, 196, and minus 4 times 7 times 69, that's going to be 1932. So if we do 196 minus 1932, we end up getting 1736. So negative 1 plus or minus the square root of negative 1736 over 14. I'm fine if we want to leave this as negative 1 plus or minus the square root 1736. I'm going to put an I in front because I lost room behind. We can't have that negative inside, and then we got a 14 on the bottom. Just for giggles' sake, if I were to reduce 1736, I have a feeling it's going to come out somewhat nicer. So 1736, if I divide it by 4, we end up at 434. We could divide by 4 again. And it doesn't come out that way. So I'm fine with us leaving this as 1736 over 14 with an I attached. Cool. Now on to the more interesting problems to me. Actually, these aren't actually more interesting, but they're more exciting because here we're looking for addition, and that means we're going to combine like terms. Minus 2 and plus 2 is going to give me 0. And then we're going to have 5i plus minus 6i is going to be minus 1i. We're done. Next one, we're going to do some double distribution. We get negative 5, and then minus 7i, minus 15i, and then we're going to have minus 21i squared. 21i squared, because I squared is negative 1, is the same as saying plus 21. Minus 7 minus 15 is going to be minus 22i, and then we have minus 5. I'm going to add those pieces together to get 16 minus 22i. And then finally, we have to do some graph analysis and deal with polynomials. Our goal here is to figure out some characteristics of this graph based on the information that we're given. So we're trying to identify intervals where this graph is increasing. I'm going to color those highlighted red. So increasing, we've got this guy right here, and this lovely guy here. And the increasing intervals, that's going to end up being from negative 1.221 to 2. And we're going from 4.096. And that looks like it's going to keep going forever, so we're going to call that infinity because we go off our graph. Okay, same thing, we do decreasing. And we're going to highlight these blue. So there and here. And those decreasing intervals are from negative infinity to negative 1.221. And then from 2 to 4.096. Noticing that I only use the x values for these intervals. All right, y-intercept, that's at 0, negative 25. My x-intercepts, negative 2.5, 0. We're going to have another one at 2, 0, and then a third one at 5, 0. The end behavior for the functions. So on the right side, we're going up and to the right. We can say this rises to the right, or I can say that as x goes to infinity, that means as x goes to the right. Y also goes to infinity, that means y goes up. On the left side, and I'm going to go this side, my graph is going up and to the left. That means that we are also rising to the left. And in terms of the mathiest notation I can do, I can say as x approaches negative infinity. In other words, as x goes to the left, y is going to go up. That means that y is going to go towards positive infinity. All right. So now we've got some fun stuff. So given the description, we've got to write a possible equation and sketch a graph. I'm going to maybe sketch this graph first and then go to an equation. So I've got intercepts at 4, 0, 2, 3, 4. Negative 5, 0, 1, 2, 3, 4, 5. And 2, 0. We've also got a y-intercept of 100. And as x goes to negative infinity, I'm going to say that goes to the left. Y goes to negative infinity also. So we have end behavior going down this way. I can't really see what's going on here. In looking at this, I'm going to just try to make this arrow go this way. All right, so I've taken care of my end behavior, one of my zeros. 2 of these show up twice. That's going to cause double roots to happen, which are bounces. And if I'm looking just at this graph, and I'm going to make an assumption, that assumption is that these are the only x-intercepts that we have. That means that I cannot cross this graph anywhere except for these x-intercepts. These are like gates that I can pass through where the x-axis is some kind of a barrier. So I'm going to make some kind of a beautiful connection between these two. And because I need 2 of these intercepts showing up twice, I'm going to bounce off this one. This is going to be a double root. So if this one is x plus 5, this root would be x minus 2 squared because I'm bouncing. And then if I bounce again, this is going to be x minus 4 squared as well. So that gives me an equation starting out as an x plus 5. We've got an x minus 2 squared and an x minus 4 squared. And the last thing I have to do is to figure out what the multiplier out front is in order for me to go through this value. And the way I do that is I plug in 0 for x. So if 100 has to be y, that's going to be some multiplier, some scale factor, times 0 plus 5 is 5. We've got 0 minus 2 is minus 2 squared. 0 minus 4 is minus 4 squared. So 5 times 4 is 20. 20 times 16 is going to be 320. So you've got 100 is equal to A times 320. When we do that, we get A is equal to 100 divided by 320. My final equation for this is going to be Y is equal to 100 divided by 320, and then that's going to be X plus 5, X minus 2 squared, and X minus 4 squared.